is pulse code modulation, or in abbreviation form PCM, pulse code modulation or PCM. Pulse code modulation is known as a digital pulse modulation technique. In fact, the pulse code modulation is quite complex compared to the analog pulse modulation technique that are PAM, PWM, and PPM. Now, elements of PCM or pulse code modulation system. The transmitter portion consisting of a low pass filter, now sampler, then quantizer, after sampling quantizer, after then encoder. So here is the analog message signal. Okay, now the output of low pass filter is goes to sampler, output of sampler is goes to quantizer, and then encoder. Ultimately it generates the PCM signal or pulse code modulated signal. So this is the transmission portion or transmitter part. Now in the transmission path there are some regenerative repeaters. So this figure is basically for transmitter, PCM transmitter. So PCM transmitter. Now in the transmission path there are some regenerative repeaters. One regenerative repeater, and here is regenerative repeaters. So there are so many regenerative repeaters in the transmission path. So this is regenerated PCM signal. This regenerative repeater is used to avoid the path loss. Okay, now these are distorted PCM signal. Okay. Now so this is transmission path, PCM transmission path. Now in the receiver path there are a regeneration circuit, then after that decoder, okay, after the reconstruction filter, okay, after that reconstruction filter, the destination point. this is the destination point. Okay, so this is the demodulation portion. So here is the input and the destination. Okay, so this figure is for receiver or PCM receiver, right? PCM receiver. Okay. Now PCM generator or PCM transmitter. The block diagram of PCM generator consisting of low pass filter, so LPF, low pass filter with cutoff frequency, with cutoff frequency FC equal to FM. So this is the low pass filter. After that, so this is band limited low pass filter. Okay, after that, sample and hold circuit. Sample and hold circuit. Now a quantizer, so a Q level, Q level quantizer. Okay, after that, binary encoder. Then parallel to serial converter. Okay, here is a timer. So here is a timer circuit. Okay, timer circuit generates the frequency, sampling frequency Fs. So here is the generator of Fs frequency or sampling frequency Fs that must be greater than equal to 2 FM, right? So we can get the PCM output from here. So this is PCM output. Okay, so this is the circuit. Now here continuous time message signal is the input. So continuous time message signal is the input. Okay, now this is band limiting low pass filter. Okay, so we can get the PCM output from here. So this is the block diagram of PCM transmitter or PCM generator, right? Transmission path, we know there are some regenerative repeaters. Okay, so a block diagram of repeater. So repeater consisting of amplitude quantizer, and decision making device. After that there is a timing circuit. Timing circuit or timer circuit. Okay, so this is regenerated PCM signal. This is distorted PCM. Signal, and this is regenerated PCM signal. Regenerated PCM signal. Okay, so this is the block diagram of regenerative repeater. Okay, now in the PCM receiver section, PCM receiver. Now in the receiver section there is a regenerator, a serial to parallel converter, serial to parallel converter. After that a DAC is there, digital to analog converter. After that sample and hold circuit, sample and hold circuit. Okay, so serial to parallel converter, this is, and this is output of regenerator goes to serial to parallel converter. This is incoming PCM signal as the input, PCM plus noise obviously signal as the input. Okay, now after sample and hold circuit, here is a timer circuit. So the output, this is for basically synchronization purpose. In between regenerative repeater, serial to parallel converter, and sample and hold circuit. This. Okay, now this goes to LPF or low pass filter, which generates actually XT, original message signal. So this is the block diagram of PCM receiver.